Nobody else pops in. So we have, this one actually wasn't too challenging. Definitely if you walk through it step by step, it's not too bad to think through. But it's a graph, so if you don't have experience with graphs, it could be an easier graph problem. It's still going to be hard to understand. Kev, you've done a couple graph problems too, and I'm going to go ahead and show you all what a couple solutions that I tried that didn't work, that I didn't really think through the problem the right way. So let's first, before anything, just go over this problem. So there's n rooms labeled from 0 to n minus 1. And all the rooms are locked except for 0. So we're starting in room 0. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. So you can see in the 0 index, you get 1. And that 1 is the key to room 1. So you could go to room 1. And in room 1, you get the key to room 2. This is room 2. In room 2, you get the key to room 3. And then you make it to room 3. And since you made it through, since it's 0 index, 0, 1, 2, and 3, then you return true because you visited all rooms. Whereas with this one, you can see that in room 0, you get the key to room 1 and room 3. So you get room 1 and room 3. And in room 1, you get the key to room 3, room 0, and room 1. And in room 3, you get the key to 0. But in none of these rooms do you get the key to 2. So 2 is an unvisited room. And so you would return false. So when you visit a room, you may find a distinct set of keys. Each key has a number on it denoting which room it unlocks, and you could take all of them with you to unlock other rooms. Given an array rooms where room I, so that would be each one of the elements inside of the array, which are actually arrays themselves, is a set of keys that you can obtain if you visited room I, return true if you can visit all the rooms, or false otherwise. And so n is going to equal the length of the rooms array. N is going to be anywhere from 2 to 1,000, so there will be anywhere from 2 to 1,000 rooms. Rooms I dot length is going to be anywhere from 0 to 1,000, so that means that each room can have up to anywhere from 0 to 1,000 keys in it. The sum of rooms I dot length is anywhere from 1 to 3,000. And rooms IJ, so all of the values inside of the inner arrays or inside of the quote-unquote rooms are going to be anywhere from 0 to n because they actually represent other rooms. All the values of rooms I are unique. So this will be a unique room. This will be a unique room. All right. So I'm going to go ahead and just share. The first one I did was I wasn't really thinking too hard about it. And right now I'm in first.js. Just see who's in here. All right, cool. We have a few people in here. Yeah, so basically what I did was I just created a key set. I looped through the rooms, and then I looped through the keys inside of the rooms. And if the key set didn't have that key yet, then I added the key. But I realized that this isn't going to work because I'm just looping through each one of these rooms, regardless of whether I have access to the room or not. So there's no like, hey, I haven't gotten.
You got half the problem.
Exactly. So I was like, oh no, this isn't gonna work. So I went to this one here in second.js, and this was where I was more on the right track.
Yeah, except you don't really need a set for your visited rooms, just a count.
You do have to keep track of which ones are visited, otherwise your stack it'll be an infinite loop.
I was thinking, why can't you just make a regular object, and you would essentially set each key equal to the room, and then you would set it to true if you actually visit that, if you have the key to that room, and then you would just go through the object at the end and say if any of them are false.
Yeah, that was actually the solution that that Leetcode
So
gave.
I have a question. So how can what is the what kind of data structure is the input here? Like rooms, is it it looks like a list, but it's more of a like
It's a
map
matrix. It's a
or
matrix, but it's supposed to represent a graph. Yeah,
okay,
it's a matrix.
I see.
Yeah, but it's
Yeah,
And
representing a
the
graph.
brackets mean that's entirely array structure.
Yeah.
and
So what was that?
so the only two things I know from graphs is like a graph has like an edge and also vertex.
Yes.
Yep.
So that's kind of what I learned today. And how
Yeah,
would
and
that
this is
like?
basically having a key to a room as a vertex or an edge.
Yep.
Okay,
Yeah.
so the
So
key is
each one of
okay.
so the nodes in this example is um the indexes of the rooms array that's being passed in. We're passing in rooms. It's a matrix. Each one of these
Hmm?
internal arrays is a quote unquote room or node. And then the key, we're calling it a key, but it's really access to another room. So this one key right here gives us access to this one indexed room. So it's actually an edge. Because this is room 0, this is room 1.
Yep.
This one key right here gives room 0 access to room 1. Yeah, so this was my second attempt at solving the problem, and I came a lot closer, but it was still just a little off. And once I had it all built out, I was having trouble figuring out exactly how to um, just debug it and get it working. So I went and did it a third time, and the third time I got it working. But let's just go into the fourth .js real quick, and I'll give everybody else an opportunity to work through this, and then I know we have several solutions between me and John, and then if anyone else comes up with a solution or wants to share something, you can definitely share that. But go ahead, um, just chat it out among yourselves for a couple of minutes, and I'll ask questions that uh, try to lead you in the right direction or make you think about something that you might not be thinking about. And John, if you want to help out with that too, since you've already solved the problem.
Yeah, how can you hear me?
Yeah, I can hear you. You got a
Not
little
too bad.
background noise, but it's all right.
Yeah, my other microphone died. All right.
Yep. So what's everyone thinking?
My first thought is just like storing the keys as we go along, making sure we have a place to keep them and reference as we go to the next room and see if we have keys for that room.
Yep, need a key ring.
Yeah, key ring. So I would do something like, I've, like, let, key ring, let key ring equal an empty array, something like that.
Lee also had a really good idea too. Is that Lee talking?
No.
Yeah, Lee, you had a really good idea too.
Yeah, you can iterate through the array, and then each index that you hit, you just you just basically say, does that value exist? And if it does, then you make that key true. And at the end, you can just iterate through the map that you've made your keyring. And if any of them are false, then you can't. Then it's false.
Sorry, could you explain that one more time?
Yeah, so like you're going through your array, right? So your first array, you have 1, 2, 3 blank, right? So like you go through, your key is 0, and at 0 you have 1, right? So now you put 1 in there, and you make 1 give it a value of true, right? And now you've gone to the next one, and now you have 2, and 2 is true, and 3 is true, right? So you know that each one of those is true, and thus because all of them are true, you can go through each of the doors.
Yes. Yeah.
So basically, you classify each index as true or false.
Exactly.
Would
So
that
you can
how?
if you want to type it out, Lee, in my code editor, just so anyone who's watching my screen can see. But basically, I think you're saying this, right? Like, so the array that's being passed in is rooms. This example right here, the first one, has 1, 2, 3, 4. So it has a length of 4. So you're saying this, right?
Right. Essentially, yes.
And then
And the way that it
every time you
determines
visit one, flag that to true instead of false. And if at the
Right.
end
So,
there's any of these that aren't all true, then we return false.
right. So we're in our for loop, and for I equals 0, right? Now we hit 1, and so now we go to the 1 index, and we make the 1 index true, right? And then we go. The only thing is that the first index is always true, right? Because
Yeah, the 0 you get a
is always
freebie
open.
Yep.
because the door's open.
how would we check if? So let me just so I understand this. So let me edit line 12 here. Let's say in this array right here where it has 0, if it had 2 here, for example, this one should come out as true, right? Because we now have access to all. And then as we're looping through, we would need to, right? The first one's going to be true. Second one, this is going to be true. This is going to be false up until when we get to here.
Yep.
Because we have access to here. So then now that we've got access to this, we need to come back here and call this true, right?
Yeah.
Okay, cool. Okay. Got it.
So the only pseudocode I wrote so far is create an array with a length of rooms and set each element to false, and then we're gonna set the first index to true because we know we're visiting this one, right?
What's stopping your loop from hitting the third iteration, which will be the list of 2, and not just changing the index 2 to true? Maybe I don't understand the for loop you're going to do.
Good question. There isn't actually a for loop here yet.
Okay. So I said loop through the array or something.
Maybe you can have a check to be sure that the key or the room that you're in isn't the number that you're setting to true in the other array. So for that second one on line 13, the 2 there, if the index is
False, then continue your iteration, maybe. I see what you're saying.
Right. So if the index equals the value inside of it, then return false.
All right.
And I mean, That's a stupid question. Of course, you guys know how to do that.
You never know.
Well, I was just going to say it's pretty easy to set the array like that. You just say let keyring equal new array, then rooms.length.fill false.
Go ahead and type it out if you want. Yep. Yeah. And then for those who just want to see what that's actually going to create, let's go ahead and, what are you calling it? Keyring?
I guess so. That's a good name. Isn't it rooms.length, or am I thinking of it wrong?
Yeah, rooms.length. Yep.
Okay.
So let's go ahead and console.log out keyring so everyone can see what this looks like. So basically we're creating a new array with the length of rooms because that's the number of nodes that exist. So with this one, it'd be 1, 2, 3, 4. We have 4 nodes and we're filling it with false. So what we get back here is an array with 4 quote unquote nodes, elements that represent nodes. And we're setting the first one a true because we are always going to start in room 0. So we know we're visiting room 0. Always.
Oh, real quick. Jimmy, have you heard of Quokka?
No. What's that?
It's pretty convenient. Basically, you can download it just here on the extensions. And like whenever you do a console log, it'll actually show it just right of the code that you console logged. So like, it's just like a little bit more convenient. And it'll like auto update if you change anything in the code and you still have that console log, like it'll run it and show it. So yeah, just
like a
mention it.
nodemon for console logs?
Yeah.
What's it called? Type it out.
Quokka. I'll type it real quick. Quokka.js, and you can, if you just over to the left, extensions. I've used it for a few weeks now, and I like it a lot. Just like kind of convenient.
Awesome. Well, I'll check it out. Yeah, I got this one for git commits that puts like on the right of the line, it shows you who actually added that line or modified that line and when the commit was made. Like it really integrates Git into your code, which is really cool. Yeah, I'll check into it for sure. All right, cool. So we have
That.
so we have this. So basically what we want to do now is actually I'll let you guys talk through it a little bit.
Okay. Well, I guess
So
we would want to look.
we're in the 0 node right now, right? Like that's where we're starting. But how do we represent that we're in the 0 node? And how do we access this one?
Do a for loop. Let I equal 0. I equal or wait. I'll just type it for a sec.
Yeah.
We'll do rooms. Right.
Well,
and then we could do.
In this case, we would be looping through every room, right?
Mm-hmm.
There are some rooms we can't loop through, though.
Maybe some if statements to check inside of the loop.
You could, to put it in the parlance of the question, you could walk past the room without unlocking it.
True,
So
but then
maybe
let's say the key to room 2 is in room 3. So what if you pass 2 because you don't have the key for that yet, and then you get to room 3 and you get access to the key, but you have already passed room 2?
I would do maybe another for loop to come back again. Like, so I collect as many keys as I can, and then I loop through one more time with, now I have all the keys that I can collect. I could have collected at the beginning.
Yeah, that's what I was going to say. It shouldn't matter. It shouldn't matter what the order of the rooms that you visit are in, because the thing is that it kind of does. It kind of does, because it's like if 301 were in the 4th index, then you'd have to, yeah.
Yeah, so what do you want to do on the first loop through?
Just my thought was just to go through and collect as many keys as I can and have an if statement. Like, so like each time I go through, I actually store what I'm allowed in my key ring.
So would you
Push into the
would
key.
you store that too?
I would do something like if like when we get to here, when we get to 2, if 2 is inside my key ring, if 2 is not inside the key ring, then just go to the next one. Like don't store 2 inside of the key ring because it doesn't exist in the key ring.
It's actually, we're overthinking it. He gave a brilliant brilliant hint. All you do is write an edge case that says if. So like you're going through and you're at 0, right? So you set 1 and 3 equal to true, right? So now your 1 and your 3 index are true. So every time you say if value at I, if rooms at I is false, then just continue. Just continue. Go to the next iteration of the loop. That way you basically can't get into that room. You can't get into that room if your key ring is false.
So explain that a little bit more. So you're saying take it step by step. So let's say we're doing this second example down here, right?
Oh, that's a thing. Continue.
They're all going to be set to
Oh,
false initially, right? So you're just going to continue on all of them?
No, you started 0. So at 0 you're going to set 1 and 3.
By the same logic that key ring 0 is set to true, any keys in room 0 we get automatically.
Yeah. So we should push the first iteration. We should push I. Whatever is inside of I should be pushed immediately into key ring. Right.
And that's before your for loop starts.
Rooms I is actually an array, though.
That's true. We might need a nested for loop to start.
Yeah, you would. That's what you would do. You would go inside. You're right. Yes, you would nest it. So if you would make a for loop where you go inside that bit. Yes.
Yeah. But it looks like Lee's doing his thing.
So if key ring I equals false, continue. So we're basically you're looping through.
This was what I wrote originally.
You're looping through this rooms array, right? And what's this rooms I right here?
Oh, I think that's just what I wrote at the beginning.
Okay.
You can take that out.
So, all right. So you're looping through this right here. If key ring I, so if key ring 0 equals false, continue. So you're basically going to be looping the first one. It's just going to continue. The second one is false. or the first one, it's going to go to else, right? Because it's true. Okay.
There we go.
Rooms you're passing an array into the key ring.
So is it looping? Wait a second.
Oh yeah. Yeah, I'm confusing myself, but I think it's the right idea. You're going into that inner array, and then you're basically saying, is the yeah.
So what if we just did something like this? So we start on 0, right? So target current node, right? And I'm not going to go into details. I'm going to let you think through a couple of these. Look at keys inside of current node. And you could call these keys, or you could call these keys neighbors. So just look at, because if we have this current node, 0, and we're targeting this current node, then we're also going to be able to target the keys inside of that current node. Whether there's 1 or whether there's 5, we're going to be able to look at those keys one by one if we wanted to. So look at the keys or the neighbors inside of the current node. In that case, then we could check if that key has already been visited. I'm trying to use language that doesn't include any technical talk, just to make it a little more challenging. We could check if that key has already been visited, and if it has, then we wouldn't want to do anything. But if it hasn't, then we can't just stay at this current node. Let's just say we're at the current node right now, and we see that 1 is one of our keys or neighbors. We haven't visited 1 yet. 1 is still false. So we would actually, to find out what keys or neighbors 1 has access to, we'd actually have to jump to 1. So check if that key has already been visited, and if it hasn't, if it has, then we just continue. If it hasn't, then we want to visit it, right? Because we need to check which neighbors or keys this one node has access to. So I'll give you one hint right now, and we're missing a data structure in this problem. And I'm thinking of it iteratively. If John, if you're looking at this too and you're like, what's he talking about? I know you have recursive and iterative. But as far as I can see, we're missing a data structure, and it's an array style data structure.
You're talking about stack.
I'm gonna just tell you it's a stack. So go ahead and think through that a little bit.
But I'm a little confused. Why can't you just do it the same? Like if you're going through each one of these nodes, right? And so you start at 0, and we've set keyring at 0 to true, right? So we say if keyring at 0 is false, continue, which
Yep.
it's not. So then we go inside and we take 1, and then we do keyring at 1 equals true, right? And now we go to the next one. We're at I equals 1, and then we say if keyring at I is false, continue. Well, it's not, because we just made 1 true, right? So keyring at 1 was just made to true. So now we go inside of it, and we see that 2 is there. So we set keyring at 2 equal to true.
Do you want to just write out the pseudocode? Because it'll be a lot easier to follow all of these instructions. So start with the keyring, you're saying, right? You're looping through this key ring, or you're looping through the rooms array? Okay, cool. Yep. So you want to loop through each room, basically.
It would only make sense to go to a room if you had the key to that room.
Key ring 1 actually equals false. Key ring 0 equals true. Key ring 2 equals true, yep. Key ring 2... How do you know whether you want to convert that key ring to true?
So basically, what you do, right, because we initialize our keyring at 0 to true, right? So our first iteration in the for loop does not go to continue. It'll go into the else statement, right? And so it says, now you're going to look inside the very first array inside your array, right? And in our first example on 37, that value is 1. So you're looping inside that array, and you say, now you're going to say keyring at that value is set to true. So keyring at 1 is set to true. And then you go to your next iteration of your for loop where I is 1. So now you're at rooms at 1, right? And we just set our keyring at 1 to true in our previous iteration, right? So now when we say if keyring at 1 is false, it's not, because in our I equals 0, we found the 1 value and set keyring at 1 to true.
All right, so we come into here. We're at the 0 node right here. If key rings rooms I, which is rooms 0, which is this one right here, equals false, continue, but it does equal true on the first one, right? Key ring.
It is keyring at I, sorry. I got confused. It is keyring at I, right. And it's not, because we initialize it on line 9 to true.
It's true.
Right?
So
now,
since it's true, then we
now we're
don't
going
just continue. We actually jump into this else clause, and we're going until for as many numbers as we have here, basically, right?
Yes, exactly. And you're going to set each one of those values in your keyring to true. So you're going to, so in 41, it would be 1, and in 42, it would be index 1 and 3.
So if the J value of the key ring equals false, convert it to true, right?
100%, yes. And now all you have to do is go to your next value of I, right? because now you've just set you've set keyring at 1 to true.
Now
So
you're
now
saying
when
start this loop over again. So now
Yes.
you're saying jump to this right here, right?
Yep.
Okay. And then in this case, we would have keyring I, which is 1 if it equals false, continue, but now it equals true, right?
100%. Yes.
Okay, so what about this? What if this first one is 6 and 8? This one room is 2 and 3, and then the only time you see 1 is later on. Then you've already passed 1. So you made the check on keyring 1. It was set to false when you checked it, and you're actually able to visit it later on. You're able to set it to true later on in the array. But since you're using I to check which key rings have true or false, how are you going to revisit that one that you passed? And what if that happens with like 25 of these indexes?
Mm.
Could I interject with an idea?
Yeah.
So I was thinking for this part, for our for loop, for the second for loop, I was thinking why not just use this opportunity, because it looks like we're check if j value of keyring is equal to false. I was thinking why not just start storing those values and start pushing them to our keyring. And for our if statement up here, it could be something like if I don't know, like I don't know how to write it, but like, if the contents of keyring is equal to the contents of the current index. So like, you go to that current index and you check if there's any matches. Actually, I guess you don't want to have any matches, because that could be a problem, because you could be opening up a door. Wait, actually,
The thing I'm trying to point out
right?
though is like let me draw it out an array. So let's say we have something like this. All right, let's say we have like 3 and 4, right? So 0, 1, 2, 3, 4. And then on this first one we have or actually on 0, 1, 2, 3 we have 1. And on 4 we have 5. 5 we have nothing. Then on 1 we have 2, and on 2 we have 0. So if you get to, let's just say we have that one right here. Let's just say
having key 0 is really not helpful.
Yeah, so key 0, this would set 3 and 4. So 0, 1, 2, that would set these two to true, right?
Well, room 0 is unlocked, so you automatically get keys 3 and 4.
Yeah, so you get 3 and 4. Then with this logic here, after room 0, we're moving to room 1. So we're checking if key ring I 1 equals false, continue. So we're just skipping this right here, even though it does have a key inside of it. It has this key inside of it. But just because we haven't gotten to this node yet, we're also missing the node 2, because we're never jumping inside of. So right here, this just
you could keep track of the rooms that you skip, of the indexes that you skip, and if you ever come across it again, you go into that array or map.
All you got to do is say, I got the key to room 3, so I'm going to go to room 3.
So what about this? Let's just say we have an array with, let's just say our 0 index goes to 4, and then our 4 doesn't go anywhere. And then we have a whole nother.
Yeah, then we have yeah.
And then
Yeah,
we
so
have,
I see we
so we
gotcha.
have our first one goes to 4, but then we go to our room 4, and our room 4 doesn't go anywhere. So what happens in
You'd be
this
stuck.
case, where you're literally iterating through all these things that you never have to iterate? You could literally just go from this
Yeah.
0 to node 4, see that node 4 doesn't go anywhere else, and break out at that point.
So this is why you want to stack,
Exactly.
because you want to put 4 into the stack, and then whatever's inside of 4 goes in the stack, and then you look through all of those.
And then we pull off 4 and we see, and then we loop through 4's neighbors or 4's quote unquote keys. If it has keys that have been visited, then we continue. If it has keys that haven't been visited, then we push those keys onto the stack and we visit those keys or neighbors next. That way we're only visiting rooms that
But how do you know when to stop? Do you just hit an empty array, or
the
is
stack
everything true?
in this case right here, you would visit the 4, and since there's nothing to push onto the stack here, since there's no like room
No,
1
I mean
and
that's an
2.
obvious one. But what about the other two? Like, how do you know when to stop in that?
Either you find an empty room or you visit them all.
So let's say the first thing on our stack is 0, right? And it's just this
That's a good.
0 node right here. And so what we do is we pull that 0 off, right? And we use it as our current. Our current is 0. So it's just rooms 0, right? And room 0 is going to give us whatever other rooms or neighbors we have access to.
Yeah, and I like the idea that someone suggested before of using a count. We could set the count equal to the number of rooms and decrement the count and put a while loop, and then once the count number hits 0, well, that wouldn't
That
work.
would be true for if this was a true. What do you like? If everything was true, then that would work, right? But if not,
Right.
then we'd have to have a break clause or
That's
statement or
what I tried.
whatever.
That's what I tried in the second one. I had rooms visited minus. Yeah, because I had I set rooms visited to rooms.length. And I was like, let me try something else.
Wait, so what about literally doing what he just said and just putting a break statement? So like if you visit an empty array, then break or something like that, and that didn't work?
You still be visiting every single room. And when you look at this, you're looking at rooms.length. You're looking at 1,000 rooms, all up to 1,000. So you're talking about 1,000 potential rooms, each with 1,000 keys. So you're talking about 1,000,000. You're guaranteeing that you're going through that whole thing.
That makes sense.
When you just don't have to. You could just, because in a case like this, where 0 has a key to 4, but 4 has nothing, it stops after basically not 2 operations, but 2 iterations through. I'm thinking while loop, but it is about 8 o'clock right now, so I would say that anyone who does want to solve this problem, definitely continue working through this. We'll go ahead and share a couple solutions. Let's see who else is in here. So we have, okay, I don't
I
know
guess
if I'll share, for those who don't want the answer to the iterative solution, the one we're working on here, too bad, I guess you're gonna get it. trying to be nice and not give a spoiler alert because I don't like people giving me the answer. I like to kind of like work through things myself. That's why I try to ask questions without like telling people what to do and just try to put things into perspective and get people to think about everything. But I'll go through my third solution because that one I'm still looking at it like how does this work, but it works. And then John, if you want to share your recursive solution, that'd be cool. I haven't seen a recursive solution at all for this yet.
Right on.
So basically what I do is the first thing I do is I create a set of unvisited rooms and then I store I inside of the set of unvisited rooms. So I end up with, let me go ahead and just show you because I think I console logged it. So if I do node 3, yeah. So in the first one, my set contains 1, 2, and 3. And it contains 1, 2, and 3 because those are the nodes that are left. I started at 1 because I knew I was visiting the 0 node already. So I have let rooms to visit. I used the spread operator on room 0 since I knew I was going to be visiting that room. So on the first example, it just gives me an array of 1 like that. And then so I do while rooms to visit is greater than 0, and rooms to visit is just the stack that I'm using. So as long as there's something on this stack, I'm going to run this while loop. So the first thing I do upon entering this while loop is I pop this 1 off of the stack. So now my stack is empty. So I check if unvisited rooms dot has current room, which is this 1. So if it doesn't have it, because you can see that it has it initially. If it doesn't have it, then I continue because I know I already deleted it from here and I already visited it. So I don't have to do anything else. But if it does have it, it means that it's a room that I haven't visited yet. So I do unvisited rooms, delete, and I delete that 1 because now it's a visited room. And this is my set of unvisited rooms. Then if the current key hasn't already been visited, so if someone got a lot of background noise over there.
Oh, Kevin.
Kev, you want to mute up if... All right. So for... Where are we? Yeah, so then I am... If the current key hasn't already been used... So if I haven't already been to this room, I am pushing all of the rooms in here onto my stack. And then I'm just returning unvisited rooms.size equals 0 because I know if there's anything left in unvisited rooms, then I haven't visited all the rooms, obviously. And you could definitely make this way more efficient too, but I'm kind of on this wave where I'm trying to make things as clear as possible and as readable as possible too. There's definitely like this unvisited rooms. I probably would have switched this to an array just set as false, the way that we were working on it in this one. And then I would have taken this for loop out of there too and just pushed the 1 onto the stack. Yeah. But yep, that's the first working solution I got.
Isn't I mean set is just a constructor object, so wouldn't it be more efficient to just do visited rooms at current room?
At current room?
Yeah.
On
line 23. Instead of using the has, can't you just do unvisited rooms at current room?
I haven't used at. I mean, as far as sets go, if I'm checking if it has a value inside of it, I just use the has.
Oh,
Yeah.
yeah.
But if I really wanted to make it more efficient, I wouldn't use this set again. Like if I wanted to go back and make it more efficient, I would just use an array with all of the nodes set to false. Because at the end of the day, the set is an object and an array would be more efficient. So
You think so?
yeah, definitely. All right, cool. And these are yours, John?
Yeah, I got them in the in one of the chats.
So
Which one?
stack visited. So this is your iterative.
That's the iterative one.
Okay. So while there's anything in the stack, pop the key off the stack, visited.add. So you're adding that key to the visited for each I in room's key.
You can pop from objects in Python.
Yep.
Yeah, you can pop from a list or an array, and then a set.
Python's pop array can actually specify which index you want it to pop, right? Like pop will just pop off the end, but if you put like pop 0, it would pop off the front, right?
Right. Pop on a list can take an index. Pop on a set can't take an index. It takes nothing. It just pops a random object in your set. Because sets in Python aren't ordered. They're unordered, so it just gives you a random one.
Gotcha. That makes sense. If I not visited and visited, then you just add that I to the visited, put that I on the stack, and yeah, nice. That's clean. And then you're just returning the length of visited and the length of rooms, and if they're equal, it's true.
Right. So where stack has the curly braces 0, originally I had the same thing as the visited. And when I started the while loop, I put, while not stack. And then when I decided, okay, it's not working, I need to initiate the 0 in there, because obviously we start at 0. Or we get the first room free. I changed it to that, and then I left the while not stack for as long as I didn't know that was not freaking letting it run. Dude, that was like an hour and a half of that making me scratch my head.
I hate it when it. I hate it
a
and love it
little.
at the same time when it's just something that small.
I kind of hate that I was like so close to the concept of how to solve this, but couldn't put it in. And like looking at this now, I'm like, yeah, this is exactly how my brain would solve this if I knew how to code.
I want to see you still work through that solution, because sometimes it's like I might not be able to see it because that's just not the way I think. But if you can solve that problem the way you're thinking, man, share that with me, because I love seeing solutions done in ways that I just would never think of, And then this is the recursive one.
Yeah, I did. Okay, I did post that one.
Okay, let's see. Visited.
So basically, it's like a little depth first search, little like helper function, I guess. It's going to do all the guts for me.
Ah, gotcha. And you put that depth first search right inside of the can visit all rooms function, huh?
Right. So that's why I call it like it helps me. It's I think I've heard it as like helper functions. I'm not sure, but basically, yeah, you let it kind of do all the grunt work, and where you see DFS 0, that's like my stack 0, because it's recursive. It's going to create its own stack, so that's my stack 0.
And you don't have to pass in visited.
What is DFS again? Sorry, I missed that.
Right, because visited is a part of what the depth first search is a part of.
Yeah.
Kind of like it's global in a way, but it's not. I mean, it's a local to the solutions method, but also global to depth first search, because it's a step in.
Yeah.
All right.
Nice. Visited.
think the other way to do it is like set it outside of the can visit all rooms, and then like you reference it as I think self.visited. And then that's like how you do it outside, like the visit outside. I'm pretty sure.
Oh yeah.
You know what I mean?
So,
Yeah.
I have a question. Sorry. So you're saying if X in visited, so like if X is in the set, how does that work? Is it just like a for loop, or how does it like find the
So
or the
basically, what I'm doing is if you see that it kind of calls itself again, so recursively. So basically, inside, let's see what line is it? Inside of the depth first search, line 10 says for I in rooms X, which X is the number that we got passed originally, which starts out at 0. But what it's doing is it's then calling itself on 10 every time it goes to a different room, and that room number is getting processed by itself by depth first search. What it's doing is that stack that we created earlier, it's doing it internally in the computer in a way. Like
Yeah.
I think the best way to describe that.
It's a concept called closure, and
Oh, okay.
yeah, closure is essentially the idea that you can that parents that children have access to their parents, but parents don't have access to their children, right? So we see that all the time when we set counters in our for loops, right? We always set the counter outside of the for loop, and we increment the counter inside the for loop, right? So we use closure constantly in our
Yeah.
iterative loop, but when you start thinking about it in more complex scenarios, it really helps to like just keep to a simple example. Otherwise, you'll confuse yourself because.
I'm gonna find you. Oh wait. If anyone wants to understand closures on a deeper level, I found this really good.